All right, so this is our last section, 4.5.
What are we doing right now?
We're going to talk about isosceles triangles. Well, the first thing we need to know is what is an isosceles triangle? Anybody have an idea of what we mean? Yes. You're thinking obtuse. Obtuse, yes.
Is it the one where like none of the sides are
That's scaling, but you're on the right track.
All the sides.
All the sides are the same. Is isosceles, but it has to have at least two sides the same.
Well, yeah, because it has to be a triangle.
No, at least two sides the same. At least two sides congruent. So triangle with all three sides the same is still isosceles because it has at least two. So let's draw a picture. Usually the way we visualize isosceles triangles, they look kind of like that. And the sides, we call the sides, two congruent sides called legs. So these two sides would be congruent. That would be a leg. That would be a leg. We call this angle the vertex angle. We call this the base, and we call these base angles. So that's an isosceles triangle with at least two sides congruent.
all about that big.
All right, and our big idea today is the isosceles triangle theorem. And we have done a little bit. We've used it in angle puzzles and that kind of thing. So we've done a little bit with it before. The isosceles triangle theorem says if two sides of a triangle are congruent, and the way we've done it before is we said if these two sides are congruent, what do we know about these two angles? They must be congruent. If two sides of a triangle are congruent, then the angles opposite them are congruent also. So if we draw a picture here, the way I usually think of it is, so here's my little isosceles triangle. If we know that these two sides are congruent, that tells us that these two angles are congruent. And I usually think of little arrows pointing across. If these two are congruent, then those two have to be congruent. And if we wrote that in symbols A, B, C, we would say if segment AB is congruent to segment BC, then angle A is congruent to angle C. So something we worked with a little bit before. So it shouldn't be a big surprise. All right, are we good there? Now, we're also going to talk about the converse of the isosceles triangle theorem. Let's remember how we make a converse of an if and a then. How do we do a converse? Put them in opposite orders. Reverse the order. Turn it around, basically. So let's write the converse. Good. All right, the converse. So we're just going to write that in, we're going to change the order. We're going to say if two angles of a triangle are congruent, then the sides opposite them are congruent. And our picture essentially looks the same, and just our arrows go the opposite direction. So we know that the angles are congruent. That tells us that the sides opposite them are congruent. So if we call this A, B, C, we just write it in the opposite order. The angle A is congruent to angle C. Then segment AB is congruent to segment BC. All right, so questions on our main theorem today. Now there are a couple of things we can figure out very easily from these theorems. In math, we call something that we can figure out easily from a theorem, we call it a corollary. So a corollary, just something else we can figure out. Kind of additional information. Our corollary says that if a line bisects the vertex angle and let's remember what does bisect mean? Cuts it perfectly in half. So we have a line that bisects the vertex angle of an isosceles triangle. Then it is also the perpendicular bisector of the base. So what does perpendicular mean? Makes a 90-degree angle. So let's draw a picture of what's going on here. So we have an isosceles triangle. We have this line that bisects the vertex angle. So if it bisects this whole vertex angle, what do we know about these two angles? This angle and this angle. If this line cuts the whole angle up there at the vertex in half, what do we know about these two angles? They're the same, they're congruent. So those two angles are congruent. This is an isosceles triangle. If this bisects this vertex angle, this is a 90-degree angle, and the base is bisected also. So if this segment cuts this angle in half, makes a 90-degree angle with the base, and it cuts the base in half also. All right, questions there? Okay, let's do a couple of examples using these ideas. It's the kind of problems that you will see on your homework and you might see on your quiz and on the final. So here's my triangle, and I'm going to say this angle is congruent to this angle, and that's also congruent to that angle. And I'm going to call this G, H, L, K, and J. And we want to know, is segment GK congruent to segment HK? And explain. So we're looking at this segment and this segment. So here's what I'm going to do. I'm going to highlight that triangle. So here's one side that we're looking at, and here's another side that we're looking at. So let's look at this triangle. That triangle I highlighted there in blue or purple, whatever it is. These two angles are the same. So what does that tell us about the two sides of the triangle? They're congruent. That's the converse of the Isosceles Triangle theorem. So that tells us that this is congruent to that. So I would say yes, and it's an isosceles triangle because these two angles are congruent. Those two sides have to be congruent. Now let's one more question here. Is HL congruent to segment HK? And we want to explain that one as well. So let me highlight those. There's HL, and there's did I say HK? Yeah. I want a KJ. So I'm looking at those two segments that I marked in red. Are those two segments sides of an isosceles triangle? No. No? They're kind of parts of sides of a triangle. So do we know anything about those sides?
No, because you don't have like two angles.
We don't have two angles that we can use to compare them. They're not sides of an entire triangle. They're parts of the sides of the big triangle. So there's not enough information. So I would say we don't know. They could be, but we don't have enough information. All right, questions on that example? All right, let's look at another one. Here's my triangle. All right, before I write anything else down, what do we know about this triangle?
Isosceles.
It's isosceles. These two angles are congruent, so those two sides are congruent. So now I'm going to say 7x minus 10 and 3x plus 6. And we want to find x. So what do we do to find x here?
Make them equal.
We have to make them equal to each other. We said it's isosceles, right? That means those two sides are the same. So that means 7x minus 10 has to equal 3x plus 6. And we know how to do this problem. Subtract 3x from both sides. We want to get x by itself. So we get 4x minus 10 equals 6. Add 10 to both sides. So we get 4x equals 16 divided by 4. And x equals 4. Well, you guys know how to solve this equation. You don't have to copy mine, you can solve it yourself. Right? And if the problem asks us to find the lengths of the sides, I can just plug in x equals 4 into one of those. They should come out the same. 3 times 4 is 12. plus 6 is 18. 7 times 4 is 28. Minus 10, 18. So that's another, we could check ourselves that way. All right, questions there? Yes.
I raised my hand now.
Oh, okay. I apologize.
So I'm confused if like you know, like if it's like a full triangle, like if they're not two separate ones, because like they're together, like if the top angle is congruent to, like if G is congruent to L,
Mhm.
then wouldn't that make like
That whole side would be congruent to, it would be congruent to this whole side, right?
yeah.
So we'd know that this side and that side were the same. To be able to figure out something about this side and this side of the triangle. But we still wouldn't have enough information to tell about that. A little later in the year, we'll talk about what else this tells us about this situation. We'll be able to figure some things out. But for now, all we could say is we don't have enough information. All right. Another example. So sometimes with these problems, we have to go in several steps. So it's not always just one piece of information is enough to solve the problem. So this is going to be one of those cases. All right, let's say we know that angle P is congruent to angle S. And we want to find measure of angle S. So let's mark what we know here. Angle P is congruent to angle S. And we need to figure out some information. Let me highlight the triangle that we have the most information about. Let's look at this triangle. Well, these two sides are the same, right? What does that tell us about these two angles? They have to be the same. So those two are the same. Does that help us? What do all three of these angles have to add up to? 180. So these two together are what? So 180 minus 50 is 130. So those two angles together are 130 degrees. Well, what do we know about them? They're congruent. They're the same. So how can I find the measure of one of them? They're both the same, and they add up to 130. Divide by 2. 130 divided by 2 is 65 degrees. So each of those is 65 degrees. Because together they are 130 degrees and they're both exactly the same. So each one has to be the same. And they have to add up to 130. So that one's 65, that one's 65. So that one has to be 65 also. So the measure of angle S equals 65 degrees. So here we had to use isosceles triangles and triangle sum. So we had to do 2 steps there. All right, let's look at one more example. We're going to add another step here. So we're getting into the kinds of problems that are asking us to remember a lot of different pieces of information that we've learned over the course of the semester. So I'm going to call this B, C, A. That's 60 degrees. That's 30 degrees, and this side length is 10, and we want to find the length of segment BA. All right. What can we figure out here? What can we figure out? 180 minus 60, right? These two are a linear pair. So 180 minus 60, what does that leave for this angle? So that has to be 120 because those are a linear pair. Now what can we figure out? Right? So we know the remote interior angles. That's one way we could look at it. It has to equal 60. So what does this one have to equal? 30. What's another way we could figure that out? 180 minus 120 minus 30. So we figure out that angle is 30 degrees. Well, if those two are the same, what does that tell us about these two sides? They have to be the same. So how long is segment BA? If this one's 10, 10. So BA equals 10. So we had to use linear pair and triangle sum or linear pair or remote interior angles. So it had several steps there. And then isosceles triangles. All right, questions there? All right, one additional piece of information. And we mentioned it right at the beginning of class. Equilateral triangles. Yes. All right, first off, equilateral. What does equilateral mean? All sides are the same. Equal means equal, lateral means side. So our first theorem, if a triangle is equilateral, then it is equiangular. So what would equiangular mean? All the angles are the same. So if we drew it in symbols, I'm just going to try, and I know these might not necessarily look exactly the same. I'm trying to get them as close as possible. If all those sides are the same, that means all the angles have to be the same. And this comes from it being an isosceles triangle. These two sides are the same, so those two angles have to be the same. But these two sides are the same, so those two angles have to be the same. And those two sides are the same, so all the angles have to be the same. So what do all the angles have to be?
60.
90, 30, 60?
60 times 3 is 180.
60 times 3 is 180.
Thank you.
So all the angles in an equilateral triangle are 60 degrees. And we can go the other way as well. If a triangle is equiangular, then it is equilateral. And the diagram, the picture would look just like this one, going in the opposite direction. So if all the angles are the same, it tells us all the sides are the same. And this comes straight from isosceles triangles. These two angles are the same, so those two sides have to be the same. But those two angles are the same, so those two sides are the same. All the sides have to be the same. All right, questions? Okay, homework.
say that you have